Alright, for the next problem from Chapter 3, we have another problem that students seem to dislike. It's an optimization problem. Now, we have a rectangular garden next to a building that is to be fenced with 120 feet of fencing. What should the lengths of the sides be to ensure the largest area? First thing you have to do is identify that this is, in fact, an optimization problem. Whenever you do that, you need a primary equation. That is, an equation that tells me what my area is. Well, before I even get that, I need to define some variables. So let's call this x, and let's call this y. You can go with width and length, or what variables you wish. But before I get a primary equation, I need variables for that primary equation. And my primary equation is area is equal to x times y. A is a dependent variable. X and y are independent. I can make them whatever I choose. The problem is, we don't know what to do with two independent variables. So we need another equation. We need an equation that links the two independent variables. That is our secondary equation. Well, I think the perimeter will serve quite nicely in that regard. X plus 2y has to equal 120. Well, we solve that for x. X would be easiest, but you could solve for y. X is equal to 120 minus 2y. I plug that back into my original primary equation, and I get A is equal to the quantity 120 minus 2y times y. Distribute and reorder. A is equal to negative 2y squared plus 120. Y. Forgot to distribute that. Okay, now this is a downwards parabola because it's second degree, and it also has a y-intercept of 0. So what we're looking for is we're looking for the maximum, the largest area. We've expressed area in terms of just one of these variables, y. We could have just as easily have expressed it in terms of x. But the point is, we now have a parabola which we can find the vertex of. That's the whole point of optimization. Now, instead of trying to convert this to vertex form, I'm just going to use the handy formula. The vertex, or at least the independent value of the vertex, normally it's x, here it's y, is negative b, so negative 120, over 2 times a, so negative 2. So that equals negative 120 over negative 4, which is going to give me, the 120 and the 4 are going to cancel, 30 feet. So the magic number for y is 30 feet. Well, what does that mean for x? Well, x is going to equal 120 minus 2 times 30 feet. 2 times 30 feet is 60. 120 minus 60 is 60. So the optimal size for x is 60 feet. So we're going to have a 60 by 30 foot enclosure, and that will ensure the largest area.